Okay, so this is how I went about machining the copper part. This is not an in-depth on how to do it. This is just an overview, so if you guys are curious, you have an understanding. Now, as you guys are familiar, the last time that I went about making something like this, I used a two-tool operation where I came along with a larger ball mill, such as, in this case, a 1/8 ball mill, to come along and rough out all the material. And then theoretically, I was going to use a smaller one, in this case a 1/16 inch, to come along and do all of the finishing work. But the problem with that is the combined machining time for both was going to clock up at just around an hour. Not terrible, but 1/16 ball mills are a bit tricky to use, shall we say. They're prone to breaking, and I only have one on hand, and there was no way I could get more in time to work on this. So I ended up ditching that plan for a new one. So the new plan was to come along with a 5/64 end mill, and as you can see, pretty much just hog out as much of the material that was on the plate as possible before I came along with a tapered tool to come and do the finishing pass. Well, one thing I didn't keep in mind was the height between the letters and the base was only 25 thousandths. So in all actuality, the amount of material that had to be removed by the tool, not a whole lot, so it's hard to say if this step was actually even necessary or not. But the machining time on it was about 20 minutes, which wasn't too bad, and it did remove some material, so hard to say if it was useless, but I wouldn't exactly call it useful. So I'm going to pretend that I didn't do that for the sake of time here and jump right into the parallel pass and talk about that. Now, as you can see, I have programmed Fusion for the approximate shape of the tapered tool. Depending upon what tool you buy, that will determine the settings that you input into Fusion 360 under the tool, but that's up to you. For my feed rate, I used 20 inches a minute, which then got bumped up to 30 on the machine because it was cutting so well, and I used a plunge feed rate of 5, which I think is pretty good. Even though I was pretty sure it was going to plunge outside the material, I just wanted to play it safe and keep the plunge rate slow. For the machining boundary, I used a silhouette. I used tool center, which means the center of the tool goes to the edge because I didn't want it trying to cut down into the vise. And I did use 10 thousandths additional offset, which means it moved the tool off the part 10 thousandths of an inch before coming back. So that way I knew if the material was a little bit oversized, it wouldn't leave any bad edges behind. For the passes, I pretty much just used the stock settings. The only thing that I changed was the step over to 4 thousandths of an inch, so it was less than the tip diameter, and Fusion 360 like that, and it left behind a good finish. Now for the linking and leads in and transitions, I kept those all stock as well. So pretty much what the toolpath did is it starts out at one corner and literally just zigzags back and forth across the part, adjusting the height as necessary, as you can see for various areas. Now the edges of the parts obviously are going to have a little bit of an angle to them, but in all actuality, because they are so thin, nobody's going to notice it, and that was a chance I was willing to take for the sake of having a tool that was going to cut this without me constantly worrying about, am I going to kill my tool? Now the machining time for this back and forth pass says it was about 51 minutes, but when you bump the machining speed up to 30, as I ran it on the machine, the machining time then drops to about 35 to 40 minutes, which, if you ask me, that's pretty respectable for a 2-inch by 2-inch plate with a 4,000th step over and a pretty measly 5,000 RPM spindle. If I had done this on a professional machine, I could have probably had the thing done in 10 to 15 minutes, but hey, I don't have a professional machine, I just have a hobby one. Now when it came to the actual cutting of this, I used a liberal application of WD-40 along with occasionally brushing the chips away just to make sure that nothing would get stuck onto the part. And being that copper has a tendency to weld onto things, I didn't want to risk that, so that's why in the time lapse you see me dumping a fair bit of WD-40 on, then brushing the chips away and repeating. That's how I pulled this off. Hope you guys found it useful.